Hello again. So, yesterday we started thinking about water and the patterns of water, the forms that we see water in, and we started thinking about the question, how is it possible that we drink the same water as dinosaurs? And so, we're going to keep thinking about that question and thinking about your ideas with that question. But today I have a new question for you. Where is water and where does it go? So think about, where do we find water and where does it go? Think about that and talk about that for just a second. Go ahead and hit pause while you answer those questions with water. Where is water and where does it go? Okay, so hopefully you thought about that and you talked about different places that we find water: oceans, rivers, streams. We even find water in the road after it rains or snows. So, and where does it go? So think about that. Where does the water go? When it rains outside and there's water, where does it go after that? Where does it go? So let's talk a little bit about water. Water, first of all, never leaves the earth. It's constantly moving through the atmosphere, the ocean, and land. This process is known as the water cycle or the hydrologic cycle. Hydro means water, so the hydrologic cycle. This cycle is driven by energy from the sun. So the sun gives water energy and it causes it to go through this cycle. So it never leaves the earth, it's always here. So the first part of the water cycle, and it's really not the first one because the cycle goes in a circle, it happens all the time. And so it can happen at any point in the water cycle, but part of the water cycle would be evaporation. So in evaporation, it's when the sun heats up water in oceans, lakes, and rivers, and some of the water turns from liquid form to what we call water vapor, and it rises into the atmosphere. If you've boiled water on a stove or you've watched your mom boil water on a stove, you'll notice that steam coming up. Or if you're in a shower, in a hot shower, and you'll see that steam is water vapor. So the sun heats it up just like we might heat up water, and it causes it to turn to this water vapor, and it rises up into the atmosphere. Water vapor is also released from plants in a process called transpiration. About 10% of the water in the atmosphere comes from plants transpiring. So evaporation and transpiration together are known as evapotranspiration. Isn't that crazy? Evapotranspiration. So that just means the heating of those water molecules into water vapor and causing it to rise into the atmosphere. So transpiration and evaporation both do that. If you're going to talk about both things, then you would say the word evapotranspiration. That's a tricky word. The next part of the water cycle is called condensation. As water vapor raises into the atmosphere, as the sun heats that water in the ocean or lake or stream or even wet water on a road, it will rise as water vapor, just like steam would rise, into the atmosphere, and it cools when it's up into the sky because it's so far away from the earth, it starts cooling down and it turns back into liquid form. When it turns back into liquid form, it's condensation, and the drops of water will settle into tiny bits of dust and form clouds. So when you're seeing clouds up in the sky, you're actually seeing water vapor that's turned back into water, and it's collecting on some dust in the sky to make the cloud. And so some examples of condensation that you might see are droplets outside of a can. If you take a cold can from the fridge and you set it on the table, you might notice water droplets on it. And that's because there was water on there, and as it warmed, there's water in the air. Sorry, there's water vapor in the air that we don't really see. It's just sitting there, kind of hanging out. And when you put something cold out, like a cold can of soda, then it will be attracted to that coldness and it will turn back to water. So that's why you have droplets of water on a can. It does it in the mirror too. Just like we were talking about, when you have a hot shower, your water might turn to steam. And so you'll see those droplets on the mirror. And that's actually water droplets that are condensating and turning back into liquid because it hit the cold surface of the moon. Okay, the next part of the water cycle is precipitation. Precipitation occurs when the water in the clouds becomes saturated, and they'll release it in the form of rain, sleet, snow, or hail. The precipitation falls down to the earth. So you've got this water, so it's vapor, it rises up, it gets so cold that it turns back to water, it connects to those dust particles and makes clouds. When there gets so much water in those clouds, it starts to fall, and that's released as rain, sleet, snow, or hail. So that's where we get our water from, or our weather from, is the water cycle. So it rises up and it's hanging out in these clouds, and when it gets heavy enough or cool enough, if it's heavy enough or cool enough, then it will fall back down. So then runoff is a part of the water cycle, and it's when rain and snow fall on the ground, and some of it's absorbed and sits in pockets underground. So underneath the ground, there'll be pockets of water. This is known as groundwater. Other precipitation runs downhill and directly into streams, rivers, or oceans. The water that flows into these bodies of water is known as runoff. So if it goes and seeps into the ground and it's kind of hanging out in the earth, then that's groundwater. But if it goes, from a mountain into a river or stream, like if you think about the mountains and then the rivers and streams go into Provo River, or different rivers that will go by, it will drip off the mountain into those rivers, and then those rivers will actually end up going to a lake. So that runoff, when it goes from the river or from the air to the running down the mountain, that's called runoff that goes into the stream. Then we have collection. Water from a runoff or precipitation and snowmelt can end up in a collection area known as an ocean or lake. So after the water runs through the river or stream, it will end up in an ocean or lake, and then it will begin again with evaporation. So that it keeps going in that cycle. So this is a picture of it. So you see some ice and snow on the mountain, and as it's melting, it's going down into a river. So that's the runoff when it goes down into the river. As it evaporates, it makes these clouds, and when the clouds get heavy enough, it falls as precipitation. So the sun gives that water the heat. So as you heat the water up, it turns into vapor, and it's so small you don't really see it. It's not fast like when you boil water. It's really small. Once in a while you can notice the steam coming off of a lake, but for the most part you don't notice it. And so it will evaporate, and then it forms clouds, and it usually goes over like a mountainous area where it's colder, and then once it gets too cold, it will fall again. And when it falls, eventually it will melt, and it will run off into the lakes and streams, and then into from the streams into the lake or the ocean. And so that's kind of the water cycle. Evaporates into the sky, condensates, turns back to water, precipitates, falls down, and as it falls down, it might run off into a stream. If it doesn't run into a stream, it might seep down into some groundwater. So that is the water cycle. Here's a different picture of the water cycle. This is showing that there's some groundwater, and there's some runoff going on. There's evaporation from the ocean, and then it condensates. It hangs out in the atmosphere. When it gets cool enough, it precipitates, and then there's snow melt and runoff again. It might go into some freshwater streams or lakes, or it might go in the ocean. So that cycle just continues and continues. So I want you to think about examples of a reservoir versus a transfer. So on your journal on page 3, write all the examples of a reservoir. An example of a reservoir would be something that holds water, like an ocean or a lake. something where the water just kind of sits there and hangs out and waits to be evaporated. And then I want you to think about transfer and write where you think there's examples of transfer, like rivers or streams might be an example of a transfer. So go ahead and fill out your journal page 3 now. Okay, so hopefully you've got some reservoir examples and some transfer examples. Remember, if I'm going too fast or if you need to watch something again, you can back it up. So we're going to talk about if some of these things are reservoirs or transfers. If you want to update your list as you go, you're welcome to update your list as you go of what's reservoirs and what's transfers. So this one is a reservoir because it's just sitting in a lake and a body of water, so it's just sitting there, so it's a reservoir. Whereas this would be transfer. It's actually pulling the groundwater up into the pipes in our home, and even some lakes actually give water for people for their homes. But when you're seeing it come out of a faucet, it's being transferred. So it's being transferred from either the groundwater or the reservoir into your house. So that's actually a transfer. So go ahead and hit pause and tell each other what one you think this one is. Okay, hopefully you guys said this one was a transfer because the water's moving down the stream and it's transferring into the pond. Okay, go ahead and tell me if you think this is a reservoir or a transfer. Okay, I think this one's actually a little of both. If you leave water in that sink or that tub, it's just going to be sitting there. And even in the toilet, it's just going to be sitting there. So it's a reservoir. But if you're transferring the water through the pipes or when you flush the toilet or you drain the bath, it's moving, so it's a transfer. So I think it could be either depending on what you're doing in the bathroom. Okay, go ahead and hit pause and make a prediction about this one, if you think it's a reservoir or a transfer. Okay, so hopefully you said this one's a reservoir because it's kind of holding that water there. And then this one is actually a reservoir because that water's frozen in that ice, so it's just sitting there waiting to be evaporated. There's also water in the lake next to it. This one would be a reservoir because it's just sitting holding the water. It's not doing anything. If you used it to drink with, then when you are taking it from your water bottle and pouring it into your mouth, then you're transferring it. But with it just sitting there, it's actually a reservoir. So now I want you to hit pause and I want you to talk to each other about, quiz each other and see if you can give them an example of something that has water and see if they can predict if it is a reservoir or a transfer. And you have to justify it. You can't just say it's a reservoir because I said so. You have to explain why it's sitting there waiting compared to actually moving somewhere. So go ahead and do that. Okay, so now we're going to do the reading jigsaw. To do the reading jigsaw, you're actually going to use the, you're actually going to use the book that, I thought I had it up. You're going to use the book that, oh, it's right here. So the science pages that I sent you some pages with some questions on them. And so we're actually going to do number 1 together. Then you're each going to do 2, 3, and 4, and we're going to share it. So number 1 says, explain how energy from the sun affects movement of water through the water cycle. So whatever page your question is on, then that's the page you'll find the answers. So on question number 1, I had this page stapled. And it says the sun provides energy that drives the water cycle. For water to evaporate, it requires energy. The sun directly supplies the energy for the evaporation. Water can evaporate when it's absorbed from the objects it touches. Most of the energy on the Earth's surface comes either directly or indirectly from the sun. So when it says on question number 1, explain how energy from the sun affects movement of water through the water cycle, you're just going to explain that and say the sun heats it up and provides the energy. Okay, each of you are going to do one of the other questions, and when you're done, you're going to share. And I'll watch for those answers when you